Our learning target for this video is students will be able to use substitution and operations with integers, fractions, and decimal numbers to evaluate an algebraic expression. So some key vocabulary we'll be talking about: substitution. We'll be reviewing operations with integers, fractions, and decimal numbers, operations being multiplication, division, subtraction, addition. Evaluate is a key word we'll be talking about, and what is an algebraic expression? So what do letters represent in math? What is a variable? So we have this 4x minus 7. The x is the variable, and a variable is simply a quantity that may change within the context of a mathematical problem or experiment. Typically, we use a single letter to represent a variable. Common letters we use in algebra are X, Y, and Z, but by all means, you can use any letter in the alphabet as a variable. So what's the difference between example 1 and example 2 here? Example 1 is 4x minus 7. Example 2 is 4x minus 7 equals 5. And then what is the academic term used for each of those examples? Do you recall that? Example 1 is an algebraic expression, 4x minus 7. Example 2 is an algebraic equation, 4x minus 7 equals 5. I hope you can see that the subtle difference is the expression does not have an equal sign. The equation does have an equal sign. So typically, an algebraic equation, you have an expression equal to a constant, or you can have an expression equal to another expression on the right side. Key difference between these: an algebraic expression, we cannot solve for x. I can't say solve for x in this problem. I can solve for x in example 2, 4x minus 7 equals 5. We can go through a process to simplify and solve for x. In example 1, which we're going to be working with today with algebraic expressions, we can evaluate the expression. So if I say, x is 5, we can figure out what's the value of that expression. If I say, x is negative 3, we can figure out the value. If I say, x is 2/5, we can figure out the value. If I say x is 7.6, we can figure out the value of this expression. So where did the multiplication sign go? So our first example here, 3x, this means 3 times x. So the coefficient is always being multiplied by the variable. The coefficient is 3 in this case, and the variable is x. You'll see a multiplication most times in our algebra class this way. So how was this in grade school? Well, you used to go 7 times 5 this way. We don't want to do that in our class because we use x a lot of times as our variable, so that gets confusing. Is it 7x or is it 7 times 5? So we don't do that, so we're going to go, usually we use parentheses, 7 times 5. It's also acceptable to use just the dot this way as well. You'll see it that way sometimes also. And then our expression here we've been working with, 4x minus 7. Again, this means 4 times the x, and then we would subtract 7 from that quantity. All right, here's our first example. So we're going to evaluate the expression 4x minus 7 when x equals negative 3. So what do you think the first step is going to be? That's right. We are going to substitute x equals negative 3, and we're going to replace x with negative 3. Now, it's important that you show the substitution work to me. So when you write this out, I want you to use parentheses for what you're replacing the x with. So it looks like this, right? It's 4 parentheses, negative 3 parentheses, minus 7. So you show that you did the substitution of negative 3 for the x. You replaced it. All right, so I want to see that in your work. What are we going to do next? That's right. Our next step is going to be to simplify and get the value of the expression. And we're going to use the order of operations to do that. Do you recall the order of operations? So there's a number of different ways teachers have taught order of operations over the years, but one classic is PEMDAS, which you might have learned. Please excuse my dear Aunt Sally. But there's basically 4 levels. The first level, the first thing you do is you remove any parentheses. So if there's any parentheses, you simplify. I shouldn't say remove. You simplify whatever's inside the parentheses down to a number. The next level is exponents. So if you have any exponents, which you don't in this example here, if you had any exponents, you would simplify those. Then the next level is multiplication and division. And multiplication is not ahead of division. You just work left to right. So if there's a division symbol first in your expression, you would do the division, and then you do multiplication, it became second. And then the last is addition and subtraction. Again, addition and subtraction are the same level. And so you just work left to right. Whatever comes first, that's what you do. So on our example here, we did the 4 times the -3. So that gives us -12 minus 7. And then when we're dealing with integers, we learned a lot in the past that it's easier just to do addition with integers. So we can change this -12 minus 7 by adding the opposite, right? So it's -12 plus -7. I put parentheses around this so that you don't get confused between the -7 and the addition operation sign here, right? So this was originally -12 minus a +7 becomes -12 plus -7. And when we add those up, we get -19. All right, example 2. This time we're going to evaluate the same expression, but we're going to say x is 5.8. So we're going to deal with a decimal number here. So same process. We are going to substitute the x with 5.8. So we get 4 times the 5.8. Again, we replace that 5.8 for the x. So it's 4 times 5.8 minus 7. Then our next step is we are going to use the order of operations to simplify this. And it's decimals. You may use a calculator in this class, so you can go 4 times the 5.8, get that number, and go from there. So 4 times 5.8 is 23.2 minus 7. So we get 23.2 plus -7, which gives us 16.2. So when x is 5.8, the value of this expression is 16.2. Our last example, let's use a fraction. So we're going to evaluate the expression 4x minus 7 when x equals 1/2. So first step, same thing, replace x with 1/2. That is the substitution process. Sometimes we use non-academic vocabulary, would be plug it in. We're going to plug in 1/2 for x, but the formal academic vocab is substitution. We're going to substitute 1/2 for x. So we get 4 times 1/2 minus 7. And then we're going to go ahead and do the order of operations on that. 4 times 1/2 is 2. So we get 2 minus 7. So then that becomes 2 plus -7. And then our answer is -5. So when x is positive 1/2, the expression itself's value is -5. Let's review real quick how we do the multiplication with the fractions, right? So if you have a calculator, you can probably, some calculators you can do this no problem, but let's just show you old school way. You're going to go 4 times 1/2, right? And I'm going to put 4 over 1. And remember, with fractions, we multiply across the top, and then we multiply across the bottom. So 4 times 1 is 4. And then 1 times 2 is 2. And then what does this mean? This means 4 divided by 2. So it's going to become 2. Or another way of thinking of this is 4 is the same as 2 times 2. And this is the same as saying 2 times 1. These are now factors, right? Because 2 times 2 are factors of 4. 2 times 1 is factors of 2. And then we simplify. common factors, the same number over the same number is always 1. So this becomes a 1, which left us with 2. All right, why don't you try one here? Your choice, student choice here. So you want to take out a piece of paper, write this down, and do the work there. You may do that. If you're comfortable doing this in your head, you may do it in your head as well. Your choice, but you are going to evaluate the expression negative 3x plus 11 when x equals negative 7. Give it a try. How did you do? So negative 3 multiplied by negative 7 plus 11. So then I'm going to get negative times a negative is a positive. So it's positive 21 plus 11. And then 21 plus 11 is 32. Did you get 32? All right, let's double check. Negative 3 times negative 7 is positive 21. And 21 plus 11 is definitely 32. So got it right. All right, let's try one now when we have a decimal number. So our x, we're going to evaluate the expression when x equals negative 4.1. Again, you may use a calculator if you want with the decimals. But if you're writing it down, show all the work the way I showed you in the examples. All right, see how we do this one. So we're going to go negative 3, parentheses, negative 4.1 plus 11. So negative times negative is positive, and negative 3 times negative 4.1 is going to be positive 12.3 plus 11. So 12.3 plus 11, let's do it. Let's break it down and make it easy in our head here. 12.3 plus 10 would be 22.3, and then I need to add one more, so it's 23.3. All right. All right, last one. So evaluate the expression negative 3x plus 11 when x equals 1/3. So I gave you a fraction here. You may want to write this one out if you're doing the other ones in your head. Go ahead and try this one out. All right, so we're going to substitute the 1/3 for x. So we know it's going to be negative times a positive is going to end up being a negative. Let's do the math here on the side. Negative 3 over 1. And then we're going to multiply that by 1 over 3. So multiply straight across, we're going to get negative 3 over positive 3. Negative over positive is going to be negative. And so 3 over 3 becomes, that's right, becomes 1. So this is going to be negative 1 plus 11. Negative 1 plus 11. And then negative 1 plus 11 becomes positive 10. So in closure, how are you feeling with this process right now? Is this kind of ring a bell for you? Are you better with the integers or the fractions or the decimals? A lot of times students have a preference for maybe the integers, but not the fractions, or some students are okay with positive integers, but they're not big fans of the negative integers and so on. Where are you?